Hi, this video is about transverse and longitudinal waves. Now, a wave is any disturbance that carries energy with it. And a wave can be categorized in different ways. If we want to make sense of the world, we often need to put things into categories. And for waves, we can categorize them based on the way they pass through matter or their medium that they're traveling through. A medium is the thing between the source of the wave and the receiver of the wave. It's the thing in the middle. So let's look at the three different ways that we can categorize waves based on how they travel through their medium. The first one I want to look at is called transverse. And a transverse wave is easily demonstrated with a slinky. So I've got a slinky here. And this is an extra long slinky, which really just means extra fun. And I'm going to stretch this slinky out. Slinkies are just big springs, and so if you shake one end of a slinky, it actually produces waves. So I'm going to start out with it in equilibrium here. Everything is at rest. And I'm going to create a disturbance with my left hand over here. And I'm going to create a transverse wave. So let's observe. All right, I'll do it again. Now you'll notice it goes across the board here, hits this hand, and one of the things that waves can do is they can bounce and reflect off of other surfaces. So you see that there. Now what makes this a transverse wave is how the medium is moving. If you just focus on the slinky, then as the wave passes through it, the slinky itself goes up and then back down. If you're just looking at the slinky, it goes up and down. But the wave is moving to the right the whole time. So this is the wave's motion, and then this is the medium motion. Okay, I'll do it again. Just as I do it again, watch this happening. Right, you'll see the wave go to the right, and you'll see the medium move up and down. Now it happens pretty fast, but if you were to focus in on just one of these coils, you'll see it does go up and down as the wave moves to the right. Now these two directions right here, we have one that's completely vertical and the other one that's completely horizontal. These form a 90-degree angle, which we can represent with this square here. And this is also called perpendicular. So when the medium and the wave are perpendicular in their motion, I can't spell and talk at the same time, then that means it's a transverse wave. So a transverse wave means perpendicular, medium, and wave. Okay, so let's look at the second kind of wave. And the second kind of wave is called longitudinal, which is just a great name. So a longitudinal wave I can also demonstrate with a slinky. Okay, but this time, instead of the medium going up and down, we're going to have the medium move along the same direction as the wave itself. So to do that, I'm just going to give this slinky a little push. Okay, let me try it again. So I'm kind of creating a little pressure wave, a little pulse, you can call it that too. And so if you focused on one of these coils, it's going to move forward and then backwards, while the wave itself goes all the way across the board. All right, so this is what makes it longitudinal. The medium this time is moving to the right and then back to the left again. So it's moving left and right. But the wave is moving to the right or the left, either way. In this case, it was moving to the right. And so these two directions, the name for this in math and physics is parallel. So when a wave disturbance is parallel to the way the medium moves back and forth, that's called a longitudinal wave. Sound waves are an example of longitudinal waves with air molecules bumping into each other left and right, passing on the wave. Now, I said there are three different ways you can categorize waves, and that's true, but the third category is really just a combination of the first two. The third category is called surface waves. And surface waves are waves that occur in water or on the ground, where if I don't have a way to illustrate this with a slinky because it's not going to give us a surface wave, but if, like, let's say we have some water waves here, and I were to draw like little dots to represent the molecules of the water along the surface of the water here, the wave is going to be moving to the right, let's say. So this is the way the wave moves. What is the medium doing here? Is it going up and down, or is it going left and right parallel to the wave? And the answer is yes, both. And how does it do both? Well, the way it does both is it not only goes up and down, but it goes to the right and to the left fully and makes a circle. So the medium is kind of constantly going in little circles here. The further down you go, the smaller the circles get. But that's what water waves are, and some kinds of earthquakes are like this, where the surface is experiencing a wave, and the little particles are carrying that wave forward by kind of rushing forward and up, and then they kind of retract back. And you can, if you've ever been to the beach, you can see this happening as waves crash onto the shore. The waves hit the ground, right, and they crash onto the shore, but they don't stay there, they get pulled back in, and it kind of creates this circular pattern. And you can even see it as waves break. You know, waves, like a really big wave will break and kind of create this looping circle that kind of circles back in and pulls it back in, having this circular motion. So those are 3 different ways that you can categorize waves based on how they affect their medium. But that's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.